Hello guys, and welcome back again to our series of tutorial in simulating microcontrollers in VS Code using the Wokwi extension. So guys, in this tutorial, I'll just continue with the very first video that I made, the very first video of 2025, where I said that we need to use AI to do the heavy work for us. So I did it in the web-based one. And I promised that in 2025 we'll be doing most of our work in VS Code because it is much more convenient, and also we have access to multiple free AI models that are embedded in Copilot. So guys, without further delay, let's repeat that project in here. All right, guys. So as I was saying, okay, last time we were in the web-based one, and then we started playing with some LEDs, and then asking Copilot, the web integrated one, to help us, and then write code to run in here by just clicking here, and then you write whatever you want and get a code, copy, and then paste it into the sketch. So this time we'll change the approach. We'll be using the VS Code extension one. And yeah, I'll start with a very basic diagram like this. So very first thing that I will do is I'll show you how to start with the project. I hope you're a beginner because most of my tutorial are for very, let's say, starters or beginners. So do a Control Shift N to open a new window on VS Code. Control Shift N, I said. And then if you want to select a file, just do Control KO. It will select a new file for you. If not, you can, if you want to start a new project in Platform IO, because that is the, I will see, the all-in-one ID that I like using for most simulation projects. So click on Platform IO. I hope you have it installed. If you don't have Platform IO installed, just go into this extension by Control Shift X or by clicking on it, and then you write Platform IO, and then it will appear somewhere out there. So you can see it's here, Platform IO IDE. This very first one, you can see it has been downloaded this million times. So then you download it. After downloading it, it will be something like this. You click on it, and then it will start initializing its core. Okay, after initializing, then it will give you this. If you already have a project, you pick a folder where there's a project. If not, click on new, create a new project, and then it will load this interface for you where you click on new project here. If you already have, you can just import it, or you can open it, okay? Or you can just choose some examples. So new project, let's say the name is Wokwi LED, something like that, okay? And then you select the board. So it has a range of board. You can use ESP32. So you can choose among all of this, but I often like the expressive ones if you can choose them, because yeah, they are, it's the manufacturer. So you see, for example, here it says expressive. So those ones I often like using them, and you can use any of this. But in this one, I'll just choose the do it, because it's been one of the very first board that was there. So do it, it's a dev kit version 1. Select it. And then the framework, we are using the Arduino framework for this very first start. And then the next one will be using the IDF framework if we get to the intermediate level. So if you keep this one selected, then it will just save it into your document. You go to the document, then you see Platform IO, and then you see project. If not, if you have to choose your own location, so just click on this, on selected, and then I often like saving stuff onto my D. So in the D, then I have a folder called Platform IO project. So these are some few projects I've been doing. So you save it here, okay? So if it is yours, okay? So this is mine. So, and after that, you just click on finish, and then it will finish. After that, it will all give you something like this, okay? You have the .pio, the .vs code. This .pio will have all of the build files, a mapping of the libraries, and this .vs code will have all of the information about the settings, and the extensions that we are using. And this one include, we have all of the header files. This library will have all of the library files. This is the source code. If you have .cpps and .c, you'll put them here, and then this text files, and this get ignore if you're using GitHub. So that was one of the requests that some of my students told me, that I have to be pushing my codes. Yeah, I have a GitHub repository, and then I often push my code, but for tutorial purposes, I don't like pushing my code on GitHub, because you will not follow it. You will just go there and then copy and then simulate and done. But I would like you to learn, so that is the purpose. But anyway, I'll be pushing from now on. So let's start with this one, and then we'll push it. So in here is where we'll be writing our code. So you only have this one inside a function. You can run it, and you'll see how it looks. So let me build it. So here you have build with control and alt, and then B, you have upload, you have test, and you can also use the CLI, the command line. So you just type .pio, and then the platform IO will get initialized, and then you can run it, and then you can build, and then you can flash it. Jet, you have built, and then it's successful. So there's nothing here. It's just a function that is being called here, this function, and then it passes it here, and then it returns the sum of those two inputs. So in this library, we don't have anything. It's just this readme. So we can add libraries. Same thing for this include, where we put all of the header files. There's nothing inside there. So this is the template that you will get. And this platform.io.init is where you'll be adding most of your things. For example, libraries, monitor speed. Okay, so in my case, I'll choose this one. You can choose, that's the border. Okay, for example, these are libraries. This is a suggestion from my AI. So Adafruit, NeoPixels, these are stuff that he suggests. So if you are using them. Okay, so guys, that is it. So last time, here's where we were, a very simple LED connected to GPIO number 4. So I'll just copy this, and then okay, here is where our magic will start getting into play. So here's Copilot. So we'll use the editor versions. You can use the chart one. So the one that we were using here is the chart one. So you chart with it, you write here something that you want, and then it does it for you. So this time we are not going to be using this open chart. We'll be using the editor one, allowing him to edit files that we have here in the directory of our project. So you click on Copilot edit, and then it will open it somewhere. And then just ask him what you want to. For example, create diagram .json file in the directory. So he has to create a diagram.json files here. So I didn't tell him what to put in, so I don't know what it will put inside. So he had started creating it, and you can see the progress here. So if it is done, this will be 100%. Okay, so he's creating using, okay, based on this, an LED connected to GPIO number 2, an LCD display connected to GPIO a push button connected to GPIO number 4, and then an appropriate grounding connection. Awesome. I didn't ask you to do all of that, but anyway, thank you. So if you are okay with whatever he has suggested here, you just say okay, and then you can open it and then see. So let's load it and see. So he's 10 times ahead of us. You can see here everything connected. So that is not what I want. Anyway, if you want to edit it, you can click here if you have the license. Okay, you see I don't have the pro license, so I cannot edit it here in my case. So in my case, I'll just press F2 to rename it, or you just rename it by yourself, and then get inside here. I'll start basic one. We are not that level first. So, okay, Control A, Control C. So this is the JSON code of this diagram. So I'll copy that and then paste it in here. Control A, Control V, and then click F2 to add the extension, which is JSON, to this. Then we'll see how it looks like. Awesome. So we got exactly what we had on this web-based one. So now, since we have this, let's get back here and tell him to create another file. For you to simulate a microcontroller in VS Code using Wokwi, you need to have a diagram.json file. That's what we've just created. You also need to have a Wokwi.toml file and fill it. So let's just tell him to create a Wokwi.toml file and then fill it. I don't know what it will put inside, so let's just give him a chance to do that and then see what he will generate. So it has started generating. So these are the models that you can use. Okay, we have 4 models that we have. We have Claude that you can use. You have Gemini. You have a GPT-4o, and then you have the O1 also from OpenAI. Okay, so we can switch among these models based on our needs. So it has created it. So a Wokwi.toml file. So let's get inside here. Version, that is cool. I like that one. Firmware, that's awesome. I love that one. And the ELF file. So this simulation and the configuration, enable LCD. Okay, all of that I don't care about it. But these 3 are really, really important. We need to have them because right now I don't have an LCD into my thing, so I can remove it. Okay. So yeah, the .pio, the build, and then the firmware. So that is here .pio, and then you get into this, and then you see into this build, or we haven't yet built. So we have this firmware.binary that should be here, and then the linker file, which is the .elf file, should also be here. Okay, awesome. So let's tell him to write a code to blink an LED connected to GPIO number 4, because our GPIO right now is connected to GPIO number 4 that you can see here, right here. So we're telling him to blink. We didn't tell him to blink every half second. We didn't tell him to blink every 1 second, but he said he's turning on every 1 second and turning off every 1 second, which is cool. I'm okay with that. So, and first, where did he write it though? That is the one thing. He knows where to write it exactly into the main function. You can see. So all of these red ones are what were there, and then the green ones are the new ones that he added. So he first defined the pins here at GPIO number 4, and then he said there's an output, and then he's blinking it here into the loop function by turning on for 1 second, then turning off by 1 second. So I like that, so I'll accept it. So then let's build it. So you can use this one to build, or you can use the command line in the terminal, okay? By just writing .pio run, and then it will build it for you. So let's build it. So the build has started. Oh shit, sorry, I didn't accept. Okay, I hope that will work. So as we were saying, if we go to this Wokwi.toml files, these are the 2 most important lines code that we first need right now. These ones, yeah, we'll get them with time, but I can even get rid of them just for us to stay in line as we go. So in here, you have the name of the board, whatever board that you chose, its name should be here. And as you can see, as it's building, we're having some temporary files that are being created. And at the end of the build, we'll have these 2 files. Okay, the firmware files and then the linker files. Both of them should be here. Awesome. So one thing that we also need to really pay attention to is if this has been including some libraries. Not yet for the now, for the time being, but after he added these LCDs that he was supposed, he will have to add the library that is required for the build of the LCD. But right now we don't have that LCD. We only have one LED that's connected to GPIO number 4, as you can see. So let's give it time to build. All right, so the linker file is ready. We now wait for the binary file, and that's also ready. And you can see them here. This is the firmware, which is the binary file, and here this is the linker file that has been generated after the build process. Awesome. And you can also check their path. You will see that this path is exactly what he has written, okay, by itself. So .pio built, .pio, then built, and then in the folder called ESP32, this is the name of the board that we chose. If your board is ESP32, it will be ESP32, and then the firmware, and you can see it here. Awesome. Now let's try to run. Okay, you can click here. That is the very first option. You click on the diagram and then click on run. And if everything's fine, it will start blinking every 1 second, as you can see here. Awesome. So on and then off. Holy cow! My diagram was modified. Ooh. Okay. Yeah. Good. So okay. Okay, I am the very first person who did it by himself. So click it here, open this, Control A, Control V, and then f2.json. It will also keep that same modification. Yes, I knew. So because I have a free version, the company doesn't want me to have all of that. But for you to avoid all of this, to same thing, Control V, and then get out of this folder, maybe go to this file, sorry, and then rename it. That will solve your issue. .json now, because I don't have money to pay. I'm sorry, Wokwi. So you can see now that things will be okay. Yeah, as I said. So, and if you start running, holy cow, I don't know why it's wanted to come back. So you can see it's okay and everything's fine. So let's close this. Let's close this. That was the very first way. Okay, click here on this diagram.json and then click on run. The second one is click on F1 and then start simulator, and it will automatically start the simulator for you. And as we said here in the main function, we are blinking it every 1 second. So turn on 1 second, turn off 1 second. So you can see here that is what is happening here. Turn on 1 second, and then turn off 1 second, turn on 1 second, turn off 1 second. Awesome. So that seems to be slow. Let's say that we tell him blink every 250 ms. Okay, it will be blinking in every 250 milliseconds. And one thing though, that I didn't tell him even where to do it, but he knows where to do it. He knows it. He said exactly into the main.cpp function. So, and you can see he himself has started writing. If you check, so it just get in and then modify this delay of 1 second to a delay of 250 seconds. The red one is what he has deleted, and then the green one is what has added. Don't you think that is really, really awesome, right? So let's build it again. So yeah, build. So let's accept all of the modification. So if you are convinced with what he has done and then you think that the task is done, you just click on done and then that will be done. Awesome. Now that we are building it, let's also give another instruction, which is add a second LED to GPIO 5, just like the one on GPIO 4. But at this time, let's be a little bit specific. Let's say in diagram.json. Okay. All right. Before we do that, so let's first verify that our build was okay and everything's fine. That it will blink every 250 milliseconds. So F1 and then start simulator. So we will see that this will be blinking now much more faster. As you can see here, every 250 milliseconds is blinking, which is quarter second. Awesome. So yeah, the code is not that much efficient. You can modify it. Pretty much you can do it. You can do everything. For example, you can just write a digital read here. Exactly. So, and you pass this, what? I said digital read. Okay. Okay. And I don't want to toggle it for now, but I just want to pass the opposite of that. That is the very first option that you could do. Am I writing in Chinese? No. Okay. So, and then get rid of all of this. This is the same thing as the code that we had. So what it's doing is read this value. If it is high, pull it down, make it low. If it is low, pull it down, make it high. So we can build that quickly and then test it. Or you can just use the toggle one that he suggested by using 6 and then, sorry, 6 and then 1. Okay, the build has started. Okay, the main function has been compiled to object code. The linker file is ready, and the binary file will be ready in just a few seconds or minutes. Okay, we're good. So F1 and then simulate. You will see that we have the same result of blinking every 250 milliseconds. Awesome. So that is good. So he's able to optimize the code as we go. So now we are telling him to add another LED, a couple of LED with the resistor, just like the one on GPIO number 4. Okay, so and we also specified, we said in diagram.json. Oh shit, I wrote the S is on the other side. Okay, he knows .json. So he's getting into this file and then modify it by adding a second LED that is connected to GPIO number 5, as you can see here. Awesome. Now one thing that I didn't tell him to do that he's doing is getting this in the main function editing, but that is definitely what I need first. I first want to go back to the diagram and then check what he has done, if it is correct or not. Yeah, yeah, that is not what I want. That is not, 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 that is not. Discard it. Although he added the LED, but we also need the resistor. And also, if you want to get to the previous command, you just the top arrow, and then you get to the your last instruction that you sent. So this is Jason. Let's give him another chance by saying add an LED to GPIO number 4, an LED and resistor. Add a second LED and a resistor to GPIO number 5, just like the one in. So what we want is like he copied all the set and then connected to GPIO number 5. So let's see if he is capable of doing it. Right now the process has started. Exactly. So you understood. So add R2 now. So let's see. So by the time that it's editing this, we can even see even the modification, and you can see that's awesome. I love that. Now I like this one. This I accept, but I didn't tell you to do anything on the main function. But anyway, we'll accept everything has done on the main function, and as you can see, it will be blinking both of them at the rate or the frequency of 250 milliseconds. Same thing. Okay, so it's like LED number 2 and LED number 1 will be blinking at the same time at the same frequency, which is kind of okay, but we didn't tell him to do that anyway. Awesome, so that is good. The next step that we want to do is I don't like this Arduino stuff, so we are right now compiling. Okay, I just launched the compiler and you can see it's compiling. It's finished compiling the main function to an object file, and the linker file is also ready, and then we wait for the binary file. By the time that we are waiting for the binary file, let's tell him to convert this into FreeRTOS, which is the vanilla FreeRTOS used by IDF, okay, or Expressive. So convert the main.cpp to FreeRTOS. So FreeRTOS just means free real-time operating system. So it's just a small operating system. Okay. Ooh, okay. Anyway, by the time that he's doing it, let's first simulate it and then see if what we've done is correct. So both LEDs should be blinking every 250 milliseconds now, as you can see, at the same time, at the same frequency. So that's what is done. Now let's go back to our main that he's editing right now. Okay. All right. So we did also ask him to have different tasks. So let's see what it will give. Yes, for sure. It created two tasks. One task for the first LED and then a second task for the second LED. And these are these two tasks. Okay. So let's accept it. I love it. So if I had to write this myself, that would take time. So if you don't know a little bit about the FreeRTOS, it's kind of operating system for microcontrollers, which can help you do multitasking much more better than using Milix in Arduino. So what he did here is like he created two tasks. The very first task is for the first LED, and then the second task is for the second LED. So you can see here LED task one, and LED task two. So what these tasks are, so you can see they only have two sections. The very first section here, from here up to here, is the setup function, and this is the loop function. Okay, and the same thing for this. So this section, okay, so this is the setup function. Okay, and this while loop, everything that is inside this while loop is what am I doing? This is the loop function. Okay, where this LED will be toggling each time. Awesome. So this you could have just, as I said, this since this is the setup function, you could have just taken this and then paste it here, or paste it into the setup function of this one. Okay. So and inside here we have these two tasks. So these are the tasks that are being called or created. So this is where the task is created, and this is the task that the implementation of the task. So and also each of them have their comments. So this is the function, which is this function, and when this task is being called, it will call this function. This is the name of the task, this is the stack size, and this is the input. So this input parameter is null, and here we have the task priority. The lower this value is, the higher the priority of the task is, and this is the task handler, and this task handler is defined up here. Okay, so it can also be null. And finally, here we have the core, and this is also pinned to the core, so you can choose the core. It has a core 0 and core 1. So you can see this task is being run on core 0, and this task is being run on core 1 because it's a dual core, okay, processor inside the processor. So good. Let's run it. Let's build it. Sorry. So it's the same thing. It's just blinking these two LEDs every 250 milliseconds. And here, this poor period to ms just means convert this value to millisecond. Okay, so whatever value that you write here, let's say 500, so it takes this value and then convert it into millisecond. So it has finished compiling our main function to object code, and then the linker file is ready from this, and then our binary file is ready, which is the firmware. So let's go with F1 and then let's try to run it again and see. We'll have the same result as the original Arduino. So you can see same thing here. Now what makes this one much more better is like we can have this as different timing because we are doing it as multitasking. So let's say we make this one 500 and this one let's say 100. Okay, we build it. Now let's tell him add a switch to GPIO, let's say 12, which control the third LED. So we are adding a third LED, which is connected to GPIO 15. So we want him to add a switch, okay, which is connected to GPIO number 12, which controls the third LED, which is connected to GPIO 15 through an interrupt function. So what it will do, it will create an ISR or an interrupt service routine, which will be connected to the switch or the push button, and that ISR, whenever it's high, it triggers GPIO number 15, where we have a third LED that will be connected to it. We good, right? So before we start it, so let's first because it's finished compiling it, let's see the result. So one of the LEDs should be blinking faster, which is 100 milliseconds, and the other one should be blinking half a second. This is 500 milliseconds, this is 100 milliseconds, as you can see. And I like FreeRTOS because of its multitasking capability. So that was it. So let's tell him to modify our diagram again. So now our diagram.json should start getting modified. Okay, so on the hardware side, we want him to add a switch, which is connected to GPIO number 12, and LED 3 and resistor R3, which should be connected to GPIO number 15. And then we modify the code, the main.cpp code, to have an interrupt that is connected to the switch or our push button. And that push button, whenever its ISR is high, it should control our LED number 3, which will be connected to GPIO number 15. If everything's fine, so let's open our diagram and see how it looks like first, because the diagram is often where the problem lies. Awesome, it's exactly what I wanted. So now I'll accept this, and then let's see in the main function what we have right now here. So now we created a button ISR, which is here. Is an interrupt service routine. This interrupt service routine should be connected to GPIO number 3, should be connected to our switch button, which is yeah, it should be connected to our switch button, and that switch button, I don't know where he passed it, but whenever this ISR is high, based on this condition, this is the debounce time, then this LED should change its state. If it was low, it should go high, and if it was high, it should go low. So by writing this digital LED here, okay, and this is the very first task. This task just help us blink this LED. I will make it 250 now. And then the second task will also blink the second LED every 500 millisecond. And then this is the setup function where we set all of this as output, LED 1 to LED 3. And since our push button is an input, then we have to make it as an input, but as a pull up, because we are using the the falling edge of this input to use it as an ISR, just I was saying exactly. So the interrupt is attached to this push button, which is GPIO number 15, I think, or 12. Yeah, GPIO number 12. Awesome. So we go and then we call these two tasks, which we had previously. And this function is not that much needed. You can remove it, but we just add this one to have this one being looping inside here. Okay, so I think we're good. So let's build it. And one thing that also we need to notice is this is uh, is this uh, is this I star function, the interrupt service routine that we are making here, is it a, a toggle function, or it is a press and release a function? So we'll test that. So our linker file is ready. So let's wait for the binary file. The binary file is also ready. You can click on this diagram and then you click on run. Then it will start running. And then we'll test our function. So you can see that this is blinking every quarter second, and this is blinking every half second. So meaning 250 millisecond, and this 500 millisecond. But this one is right now off. It's waiting for the edge of this one to fall. So if we press it, you will see that it's on. But when I release, it goes off. When I press and I release, and then it goes off. So as you can see, press, release, and still on, then press off, then press on, then press off, then press on, then press off. So that means our service routine that we have here is a toggle button. So that means toggle just means when you press, it keeps on, waiting for the next stage to change. When this button, the edge of this button falls, or in the falling edge, this state, the LED state change here, as you can see here. So if the LED state was high, it goes low, and if it was low, it goes high. Simple as that, right? So I hope you guys are with me and you get everything. Okay. All right. So yeah. So we can also keep on adding, but I don't like the way the diagrams looks, because it's also kind of freaking bad. Although it's working, but I don't like it. So what I will do, I'll control A this and then edit it into the GUI, because I like things to be a little bit cleaner. I don't like. So this we can move it maybe to this point. So I think P is to flip. R. Awesome. So okay, this to me is kind of okay, but it's a little bit annoying because okay, this is a little bit better. Now that is good, and I also change, for example, the color of this one to be, let's say, green. And all of this you can also do it here, okay, in VS Code yourself. If you don't, if you like, for example, the attribute of each of these LEDs. If you look into this resistor, for example, this one, if you want, you can just make it green by writing green over there, and you are good. So green, it will be green. If you change this one, let's say to blue, it will be blue. So something like that. Okay. So but this wiring, I like to be a little bit cleaner, and this wire, you can also change the color of the wire by just writing the color, the name of the color. But I would like them, all of them, these cathode connected part to be all black. Okay. Or so that is one thing. And another thing that I would also love to add is, let's say, a simple, I don't know, I need okay, you can add this, and then in the attribute, where did I even put that hell shit? This is a button, this is a resistor. Yeah, I think it's this. So in its attribute here, let's just make it I2C. I2C. Am I correct? Or I2C. Yeah, I want to make it I2C ones, as because this is just Okay, this. So the attribute is what for I2C? Let me first get rid of this one. Yeah, it's I2C. Oh, pins. You have to add the attribute name, which is pins. Okay, so I'll add this one. And yeah, let's say we place it here, okay? And then let's say that we add a VCC or a 5 volt. Oh, what am I doing? And then we add a grounding one. So I'll connect this to this. And then we add a GND symbol to the ground of this, which is this. And then we connect this SDA to GPIO number 21, which is the default SDA of the ESP32, and you can also use some others, okay? And then we add this SCL or serial clock to GPIO number 22, which is also considered as a default. Okay, so I'll move this ESP32 out a little bit, and then I'll move this wire to be like this. Awesome. So this should be yellow. You can give whatever color that you like, but I like to have my SCL to be yellow, and my SDA could stay green. Awesome. So let's copy this. Oh, what am I doing? I don't want to save anything. Control A, Control C, and then give it. So yeah, you can also write it here. It will do it for you as we've tested, but I don't like it because it doesn't position things the way I want. So, and we'll edit and then rename it as .json, and let's see how it looks like. Beautiful. So right now, when we run this, this will not be working because we don't have the code for this. But at least our push button should be working, and our LED should be blinking properly. So if I press this, you see it's on, and if I press this, so this interrupt function is working as a toggler interrupt. So we can also change this so that when you press and then you leave it and then it turns off. Okay, but I like the toggling one. So now let's tell him that we have added 16 times 2 I2C LCD base LCD. Okay, let's tell him to display the state of LED 3 on the LCD, and add all the required labs. Okay, so this require an I2C library to be added into the platform io.init. So we want him first to display the state of LED 3 on here. For example, if LED 3 is on, it should display on. If LED 3 is off, it should display off. That is one thing. But for this to be accomplished, we need to add all the library required, the crystal something something. So, but that's why I'm asking him to do that for us. Instead of me going here and then look for the library and then come and then place it in, he will do it for us. And also in the main function, we need to add also the function that will display the state of the LED by writing the code for it. So it should also do it for us. So right now it's working on the main. I don't know if it will directly jump into platform io.init function file where it should add the libraries. Yes, exactly. It jumped into it and it's doing it for us also. So guys, I hope he's done. He said he's done, so let's check. Oh no, he said it's still writing because in terms of percentage, we are 79, 90%, 99%. And for a moment, yeah, he said 100%. So that means he's done. So the very first thing that we need to check is the library. Okay. So we go to the library. Yeah, I hope this library is okay. Yeah, that is cool. So I'll accept this one first. That is cool. And you can see that platform IO is directly configuring by installing the library. And you see the library has been installed and then the metadata has been updated. Awesome. Now let's get back to our main.cpp function. You can see in here that he has added these green sections. So that means he didn't modify the very first task that we have by just notifying here. I don't like this one, but yeah, let's keep it because he's doing this one as a handler of the new task that will be created. But anyway, so he included wire, which is the mother of I2C, and then the liquid crystal. So this is the address of our LCD, and then this is the number of columns that the LCD has, and this is the number of rows that the LCD has. Okay, or the interface. I just said it. We can adjust it based on what we need. And inside this function, which is the void LCD function, we have a function that can clear, we have a function that can set it, we have a function that can print the state, and then where it has to print, for example, you set the cursor to row 0 and column 1, and then when it's on and off, based on that, it displays this function, which is awesome. I love that. Now, how will you know that it's on or off? By checking the state of this ISR, this interrupt. If this interrupt has been called, whenever this function, the handler of this task has been called, so that means someone has pressed that button, and then it will send that flag to this function, right? To tell him, oh, someone has pressed it. If it was on, then it will display on. If it was off, then it will display off. So that is as easy as we might think. So this is in the first LED. Check if it's needed. Yeah, definitely not. And in the function, yeah, you need to begin our LCD, the wire, and then init it, and then the backlight has to be turned on, and LCD print, monitor, update. All of these are cool, but they can be really simplified. This is, but it's, I would say, a little bit high level, but I'll modify it for you. But anyway, before I modify it, let's first test his code. It will work. It will work, but we could, for example, get rid of all of this function by just calling them individually, because this, whatever we have there is just here, just clear and then set, clear and set. But he put them, all of them, into one function, which is this. That is awesome. So our library has been updated, and then it has started compiling. So it has compiled the library of the LCD, the Arduino hardware serial.cpp has been also done, the IP addresses, the builder, yeah, the stream street. So all of this will be compiled now. So that is just the beginning. As we have this, what will be the next thing that we can do? Oh, let's tell him to simplify the code and optimize it. Simplify the entire code and add all the comments required for other developer to understand the code. So yeah, we are waiting for the build to finish, then we'll tell him to make it a little bit simpler by for example, this notification flag is really not that much needed. You can just set this as a state by here, setting as false, and then looping over and over to check that state and then write it into the LCD. But that is the next step. So he said it's done. So let's test his code. Moment of truth has come. So let's see. Now this should definitely initialized, and it should also print LCD LED free monitor status. You can see it's off. Let me bring it down. Okay, guys, let me bring it down. Let me bring it down. Let me bring it down. This is awesome. So this has been done in just a very short period of time. So LED number 3 status, you can see it's off. Then when we press this push button, and then you see it should update it about off. Holy shit! It said that the task has overflow. So he is crazy. He didn't know that he has to add. Where is that LED task even? Where is that LED task? Where is that LED task? Where is that LED task? Which task is even that? The task has overflow. So which task? I think it's LED number 2. So if it's just LED number 2 task, let's set it to 3000. Okay. So this stack size defines which size of the memory that we are of the microcontroller's memory that we are given to that task, specific task to run on. So if this stack is small, it will overflow. So, and I think that is the only task that we have here that is calling this LCD. So I hope that is cool. So let's build it again. So you could see that on here, we couldn't because the stack size was small. So let's give 3000 as stack size, and then we see how it will behave. So the main function has been compiled to object code, and the next one will be our linker file, which is also ready here. And the final one is the firmware, which will be released in binary. Cool, awesome. Oh, let me restart. Okay, let me restart. Don't be in a hurry. Don't be in a hurry. Cool. So I hope that things will work right now. So the LED, you can see the status is right now off. So when we click on this button, and then so yep, yep, yep. So it is still small. So let me check. I think it might be the first task, or both of them. Yeah, it is here also. So where's that first task? I will also make it 3000. So as for the priority, that doesn't really matter to me because both of them are not that much useful tasks. But if I had to give more priority to one of those tasks, I will check on both of those. For example, this task one has that function being called. Oh, I see. It's only LED one though. It's only this LED task one which has what we need. So even bringing this one low to like let's say 1000 or 2000 even, it's okay. And we give more priority to this one, and then we set the priority level of this to be, let's say, 2. So we give more priority to this task because we know it's running both the LED and also running the ISR and also updating the LCD. Him, okay, this task alone. Okay. Anyway, I'll accept both, but I think 2000 is okay. Yeah, so the main file has been compiled to object code, and then the firmware, the linker file is ready. So let's give it a second for the binary file to be ready. That's cool. It's also here. So then let's restart our simulator and see what we'll get as a result. Okay, we got this. It is still slow. I don't know if it's my internet or what because I'm also working online. Okay, so yeah, on, that is cool. Off, that is cool. On, that is cool. Off, that is cool. The code is still not that much robust, but it's still okay. And I think if I have to make this one much more faster, these delays could be reduced. For example, in here, this is two. Okay, only have these two. Awesome. So let me bring this task to, yeah, I think 3000 is definitely okay. 3000, and this also 3000. Yeah, but anyway, we don't have any overflow. Everything works fine. That is cool. But we need to optimize the code to make it easier. So that is our next instruction that will be given to this. But in the meantime, let's compile it with 3000, 3000 in terms of stack size for both tasks. So guys, that result, our main file has been compiled to object code, as you can see here, and our linker file is ready. And next time is our binary, okay, that can be used as our firmware. That's also ready. So let's restart our simulator. And I'm using the internet. Things might be slower, guys. I'm sorry for that. So our two LEDs should be blinking at different frequency. This is blinking faster than this one because this is 250 millisecond. This is 500 millisecond. And you can see that the LED number 3 is off. And you can see it's reading here LED 3 status off. So if I press this push button, our ISIS has been updated. And then also you know that I2C is a little bit slower, but not that much. But anyway, it has been updated on this side. So I click on it, then turns off, and then you see over there. Cool. So one thing that is really bad about this is like this value shouldn't be updated. It's only this off status that should be updated, not the whole shit. So by that you could just this function update. So instead of you updating this function, it's only this one that's supposed to be updated all the time. So you can just remove this. You could just remove that and then directly pass it into the loop function, and then it'll be printed all the time, because at any time that I click on the button, the whole screen gets erased, and then print LED 3 status, and then print this one. All of that can be optimized. But anyway, we need to add comment on each of these functions. That is really important. So let's ask him to add all of the comment and also optimize the code for readability and portability too. So yeah, what will be our next element to be added? So I think we've already covered all of the things we did on the very first video with the web-based one, and we've added an LCD which was not added onto the very first one. We'll continue with a little bit of intermediate levels where we can do some HTTP TCP protocols in Wokwi, and then some MQTTs, which are much more better and useful. So we are heading there, we are heading there much more. Same thing, it's just keeping the older update on the screen, which I really don't like it, but it's fine. You can just cut it and paste it somewhere else. So now these two tags are okay, and he got rid of all of this and then set them as defined. I don't like that much. I think this is far better, because each defined as macros, whenever you run your code, because these ones, they don't get saved. You might think it's a kind of memory saving, but they get redefined. They are volatile compared to constant. I think there's not that much benefit of getting this defined than what we had as constant. But what I really love is these definitions, these interrupt handlers. Everything has been added, and cool, awesome. So let's build this. Now, while we are building, let's tell him to add readme dot md file. Okay, md stands for markdown, and fill it accordingly. I'm not good in I'm not good at your guys' language, which is English. I'm a French speaker, so we'll add a README file for this, and then we'll fill it accordingly. So he has to describe what the project is about, what is being done, how things are connected. So all of that should be into our readme.md file. So it will create a new file here. You can see readme.md, and this should give the description of all of our file. And also, one thing that is really important is the preview of our code. If the readme file has, because the preview is extremely important. For example, for me, if I head on over onto any GitHub repository, the very first thing that I see is how to use it, how to run it, and the preview, because the preview gives me a little bit of idea of what the person is doing. So you can see this table gives you all the pin connections, which is awesome. I love this. And I love this MIT license. That is cool. That's what I've been using most of the time. So that's why definitely just added. He knows me more than I know myself. So, and the order also the name. So one thing that I would like to do is to add the preview of the code to the readme file. So that is really important to me. I don't know if it's important to most of you guys, but it is important to me. So since we finished building, let's first run it and then see how the simulation looks like while it's working on the readme file. Come on, internet, be fast, please. I don't have to make this video to be very, very long. System start. I love that. Okay, so for it to update these GPIO times, we have system start that displays on the screen. I love that. So when we press on this LCD and then we got LCD, but honestly, updating this value doesn't really make any sense. You see, I don't like that. But anyway, things look cool. So it's adding the preview on the code. I'll just see one moment if I can definitely correct this freaking bad thing. Okay. Sorry guys. Where is the LCD function? I'll just remove this nonsense things here. I'll get rid of this, and then we look for this function where it's been called, and that is enough for us. So it is in here, right? So awesome. So whenever we get our interrupt, okay, this one is done. So let's first check it. Okay, we added the preview, which I love it. So let's see how it looks like. Okay. Okay. Awesome. I love this. So this is the readme file. So that is cool. And let me build it. Oh, one thing that I didn't take into consideration is the clear function. Okay, but anyway, because the clear function might clear my looping LCD LED3 status. But anyway, so system starts. It's okay, that's cool. Yeah, I knew the clear function. But anyway, so if you do this, get on, yeah, the clear function will clear it. Yeah, I knew that. I love that. Yeah, man. Yeah. So if you don't want it, just remove your clear function and then update onto that same position, whatever you want to do it. Where was that function? Yeah, here. So I didn't take into consideration my clear function. I will just get rid of it. Oh, oh, nigga, you crazy. Just bring that function where it was and you are cool. But anyway, I'll first go with this first option. So you just remove the clear function and then everything stays where they were before. Where is it saying? Okay, cool. So now that we have our readme file that's ready and everything's cool, let's create a new terminal and then start the GitHub repository. Control Shift this. So let's start a repository into this and then publish it. So this is kind of beginner, the very first video we'll be doing in the GitHub in VS Code extension. Okay, so get init. Sorry. So an empty one has been initialized. So git add, and after we add all of this, so git commit. So at this point, our commit image will be just like a simple LED blink in Wokwi with LCD using VS Code and platform IO. So let's say that this is our commit message, but holy cow, it's extremely important that you get a version. I work with a guy. If you don't add any version to whatever fuck you're doing, just get mad at you. So let's say that this is the very first version, okay, 1.0.0, okay, and then let's commit this. Cool. So let me check the status before I start with some other news. Cool, that's okay. Now let's, since the build has done, let's run it again and see what we get. And I think the very best thing is just get the function where it was before, instead of bringing it into a place which doesn't really definitely make sense. Oh shit, without our clear, this system shit will not go away. But anyway, yes, I knew that. I knew that. But I love this. It's much more better than, oh shit. Yeah, that is not cool. But it's better to get it to where it was just up here. And that system start, we can get rid of it if we want. And also we get rid of our clear function. And then we bring our clear function below this. Okay, and update it. So Control Shift N. So guys, I don't want to waste you guys time. This is a very beginner project that you can try with, and this to me is a way for us to start things in this 2025. We'll be using Claude, and I also use DeepSeek, but I often code in Chinese. I don't know if I'm using Chinese, you guys can understand, but I think we'll be using the international platform, which is Copilot, and embed these 4 AI models that we can use. Okay, so let's run it and see how it looks like. Now, by the time that we are running it, so let me do a Control Shift and Control Shift, and then since we've had a modification here, it says that we've added some modification here. So let's add that, okay, with gate, and then we commit that. My computer is getting slow. And the commit message will be the LCD update function, I think, was restored with clear function. But the version, that is extremely important. So the version of this is v1.0.1. And then let's push that quickly and you guys can see how things look like. Now, gate status, just for me to confirm things. Okay. Now, I'm in China. The bad news for you guys is like gate push doesn't work properly in China. I don't know why, because of the regulation, and they don't use that much gate here. They use gatey. Gatey is extremely good. It's kind of a Chinese version of GateUp. They do almost everything, and even GateUp gate commands work into it. So cool, awesome. I think this is enough. So if I do gate push, it will fail. So first, because the repository hasn't yet been created, that is the very first thing. And second is because the VPN, the proxy will be blocked. So I'll use the desktop one of GitHub and then create a repository and then push it quickly so that I can end this video, guys. So we come to, we click here into file and then add local repository and then choose where the hell is located. I think it is on my desktop and it's called this one. Okay, it seems like it's not. It seems like it's Wokwi something LED. Okay, I think it's this. Okay, select it and then add it. Okay, so you can see that you just click on this and then it will tell you you want to name your repository this one. You say fine. If you want to change, you can change. So we have ESP32 Wokwi LED, we have LED LCD, we have LCD, we have a switch or a push button. So simple LED and LCD simulation using the ESP32 and in platform IO with the Arduino framework and FreeRTOS. So FreeRTOS is just the vanilla FreeRTOS that these guys ideas just took it and modified its organization. So if you're working for a company, you can choose it. If not, just publish it. So let's wait for it. It will fetch it and then it will just push it on GitHub. And I will show you guys what we have on GitHub. Awesome. We good. We good, man. We good. So let's show you. You can see it where this file is on your computer by clicking on Show on Explorer, or you can see it on the web by clicking on View and GitHub. So this is my default browser. If yours is Google, it will open Google, and we are here. So this is GitHub. This is my names, and this is the project I've just created. And you can see everything looks pretty well, awesome and cool. So that is it, guys. And if you want to see how it looks like, for example, next time that you come in and you want to run this and just test it if things are working, you just click here. If you have GitHub desktop, you just click on this GitHub desktop. If you don't have, just download the zip file and then open it into whatever, and then click on open in VS Code. And when you open in VS Code, you have this one. If you have this one, the very first thing that you need to do is to build it. After you build it, you click on F1 and then run. That is one thing. Or you just click on the diagram here and then simulate it. So guys, as we said, so the next step that we'll be also thinking is how to use these lives, how to use this include, because I don't trust these nonsense things of putting library here. This library is owned by this guy, and tomorrow he can change the code. If he changes the code, our things will not work anymore. The best practice is always get your libraries into the library folder. So let's click on F1 and then make sure that what we have on the browser, it's working. Many people push codes on GitHub that don't work. So that is not a very good thing. You will spend too much time debugging than even doing it yourself from scratch. So click on this, it will turn on. Click on this, it will turn off. And confirm that that's what you have onto your README here. So let me open it so that we can be all on the same page. So it says that the LED one is going to GPIO number 4, that is correct. That LED number 2 is going to GPIO number 5, that is correct. That LED 3 is going to GPIO number 15, that is correct. That the push button is going to GPIO number 12, that is correct. That the LCD serial data port is connected to GPIO number 21, that is correct. That the serial clock of the LCD is going to GPIO number 22, that is also correct. And these are the values of the resistors that's connected to the LEDs, that is also correct. So now, features multi-LED using FreeRTOS, push button interrupt handling, real-time status display on the LCD, that is correct, and task scheduling on different CPUs cores, which is core 0 and core 1, and also different, I would say, priority level settings, and hardware debouncing because we are doing the press button, and we're using platform IO is the Arduino framework. And yeah, that's the preview of the code. Awesome. So I think everything looks okay. And guys, I hope that this will be helpful to you guys, and see you in another video.